This is AQA A-Level Chemistry, and we're looking at periodicity year 13 topic. So it follows on from year 12 but has a lot of additional information. As always, I'm going to recommend that you pause, have a go at each activity for yourself and see how you're progressing with it. In this final video in a series of 3 for this topic, we are going to look at the oxides of period 3 reacting with acids. We're going to describe how the oxides react with bases, and we're going to look at equations for each of those reactions. So, what would you predict that metal oxides will react with? Are they acids or alkalis, or which would they react with? So metal oxides are basic. That's the first thing to talk about here. That means they're going to be neutralized by acids. That's what they are going to react with. So what would you predict that non-metal oxides would react with? Acids or alkalis or bases, and why? Again, non-metal oxides are acidic. We spoke about both of these in the previous video, but remember, sulfur dioxide is acidic. It causes acid rain. That's your start point to remember everything else around it if you're trying to find ways to simplify and group together information. If it's acidic, that means it will be neutralized by alkalis. So, what reactions will take place when sodium, magnesium, silicon, phosphorus and sulfur oxides react in neutralization reactions? That's what we're looking for here. So let's start with sodium oxide. If I react sodium oxide with HCl, I'm going to make sodium chloride and I'm going to make water. And this is an equation that we saw in the first video of this topic. If I take magnesium oxide, a basic oxide, and I react that with hydrochloric acid, I end up with magnesium chloride and I end up with H2O. Now you can see there that what I actually need to do is also balance that equation, and that makes it 2HCl. Moving on to silicon dioxide, you can see here that it will react actually, but it reacts with NaOH. You'll also notice I've missed aluminium for reasons that we will come to. There's a reason it's not on that list. It will only react with silicon dioxide if it's hot, concentrated sodium hydroxide. It's not an equation that happens readily. It's not an equation that happens easily, but it is important that you remember that this is what we make: Na2, SiO3 and H2O. You could be asked to replicate that equation in an exam. Moving on to potentially more familiar things, we've got H3PO4, that's phosphoric acid. If I react that with a base, I'm going to make sodium phosphate and I'm going to make water. It's a more straightforward reaction. And taking a look at SO2, SO2 actually reacts with sodium hydroxide to make sodium hydrogen sulfate. That sodium hydrogen sulfate can then go on to react with sodium hydroxide to make sodium sulfate and water. So we're actually seeing that as a two-step process. It could be done as a one-step process. That would also be valid. Let's move on a little bit because aluminium does stand out as different. Why did we not include it in the list? What could it do? And also, what word do we use to describe the aluminium oxide? The word we're looking for is that it's amphoteric. And again, a chance for you to stop and think. If you didn't get that, can you remember what that means? And what we're looking at is that means that the aluminium oxide can act as an acid or as a base. So you need to be able to write equations for either of them. In the first instance, I'm going to show aluminium oxide reacting with hydrochloric acid, so acting as a base. Well, I know that I'm going to make a salt. In this case, that will be aluminium chloride, and I know I'll make water. I then need to balance it. I need my 2 AlCl3. That means I need 6 HCl. And because I've got 6 H's, that now means I need 3 H2O. So you can work out aluminium oxide acting as a base. You can do that with any acid, and you follow the same simple rules that you would have followed from GCSE onwards. But what about if it acts as a base? This is where it gets a little bit more complicated and a little bit more memory might come into play on this one. Let's react it with NaOH. Now in this reaction, you're also going to need to remember that we have H2O as a reagent as well. And when we do that, we make sodium aluminium hydroxide, NaAlOH4. Not a compound that you'll be familiar with potentially, or that you will see anywhere outside this very specific circumstance. Commonly called sodium aluminate. Let's take a look at the balancing. I need 2 NaOH, 3 H2O, and 2 of the NaAlOH4. Now, as much as you're not going to see that anywhere else, it's entirely feasible that you could be asked to replicate that within an exam. So practicing these, checking that you know them, that you remember them, is important. Let's finish off with a couple of exam questions. So magnesium oxide, a basic oxide. Give me an equation that would show it acting as a base. You just need to react it with an acid. We've already done this. MgO and HCl goes to magnesium chloride and water. We then simply need to balance it. And all this needs is a 2HCl. Phosphorus oxide acting as an acidic oxide. So let's react that P4O10 with sodium hydroxide. And we are going to make sodium phosphate, a salt, and we're going to make water. Again, we need to balance this. I need 4 of the Na3PO4. That means I need 12 of the NaOH. It means I need 6 H2O. We're dealing with quite big numbers there. Couple more questions just to finish off. Why would silicon dioxide be described as an acidic oxide even though it's insoluble in water? Well, it's because very strong bases at high temperature can neutralize it. Aluminium oxide is amphoteric. What would the equation be between aluminium oxide and hydrochloric acid? This is straight from the notes and straight from earlier in the video. We've got the equation here. And if we added sodium hydroxide, this is an example of you needing to remember that equation that I spoke about. Making the sodium aluminate that we see here, being able to balance it, remembering the state symbols. So that takes us to the end of this topic, the end of this video. Thank you for listening, and goodbye.